When we think about what actually starts puberty, most of us probably picture some kind of biological switch just flipping on. But what if it's not a switch at all? What if it's more like a really complex conversation happening inside our bodies? Let's tune in. So, is it just a simple alarm clock set to go off at a certain age? Or is it something way more dynamic? We're going to explore how it's actually this intricate dialogue where all these different signals have to line up at just the right time. All right, so let's dive right into that central idea. Section 1, we're calling it a delicate conversation. Yeah, you can pretty much forget everything you thought you knew about this being some straightforward process. Here's the most important thing to get. Puberty isn't just about getting older. It's a carefully orchestrated event. Seriously, think of it like a symphony. You've got hormones, you've got the body's energy levels, and you even have signals from the outside world, and they all have to play their part in harmony to get this thing started. Okay, so who are the key players in this symphony? Let's meet the messengers that really kick the whole thing off, the hormones. Right at the very top, pulling the strings are these really special cells. They're called GnRH neurons, and you can basically think of them as the ones holding the start button for puberty. So what are they exactly? Well, GnRH neurons are specialized cells in the brain, and their job is to release the master hormone for puberty, which is called, you guessed it, GnRH. It's like the very first domino to fall. It sends out the signal that starts the entire chain reaction. But, okay, this is where it gets really cool. How do these master neurons even get their instructions? Well, it turns out that another hormone, thyroid hormone, T3, actually acts as their guide. So you have a hormone that's tied to our metabolism, literally telling the reproductive process when to begin. It's this beautiful, interconnected cascade that gets everything going. And that brings us to a super important point. It's not just about hormones talking to other hormones. The body's energy balance, its metabolism, has a really powerful voice in this whole conversation. And you can see this playing out in two totally opposite ways. On one hand, studies have shown that higher body fat in girls can actually push puberty to start earlier. But then on the flip side, kids with poorly controlled type 1 diabetes often have major delays in puberty. It's just clear as day proof that the body's energy situation is a massive factor in the timing of it all. So if it's such a delicate balance, what happens when that timing gets all thrown off? This brings us to when the timeline shifts, and we're going to look at some of the disorders and disruptors that can interrupt this conversation. One of the big ones is when puberty starts, like way too early. This condition is known as central precocious puberty, or CPP. It's like the body's internal clock just decides to start the race long before it was supposed to. And this might be more common than you realize. One study found that over 20% of the patients they looked at were diagnosed with CPP. So this isn't some super rare issue. It's a real clinical challenge for a lot of kids. Which, of course, leads to a pretty important question. What's the big deal? What's the actual physical impact when this whole process starts so early? What are the consequences? Well, the research is really clear on this one. The consequences include short final height and bone age advancement. So what that means in simple terms is that the bones mature way too fast and then they stop growing too soon, which can often lead to a person being shorter in adulthood. So what's behind this? Well, remember that thyroid hormone T3 we were just talking about? Take a look at this chart. You can see that as T3 levels go from normal up to high, the odds of being diagnosed with CPP jump up pretty significantly. It's such a powerful visual of how tightly connected all these systems are. And get this, the conversation can also be disrupted from the outside. Research is pointing to environmental chemicals that act as endocrine disruptors. For instance, being exposed to things like PFES chemicals has been linked to higher odds of CPP in girls, while mercury exposure can actually mess with sex hormone levels before puberty is even supposed to begin. And it's not just about CPP. You've got other conditions that can change this whole conversation too. There's polycystic ovary syndrome, or PCOS, which affects reproductive hormones. There's congenital adrenal hyperplasia, which messes with the adrenal glands, and Klinefelter syndrome, a genetic condition in boys that can change the entire path of puberty. Every single one of these shows just how many different things can influence this critical time of development. Okay, let's pull back and look at the big picture. Why does any of this matter? What does it all mean for how we think about health during these crucial years? So, what's the bottom line here? Puberty is not some rigid, fixed program. It's a super sensitive and dynamic conversation. It's a dialogue happening between hormones like GnRH and T3, and it's listening really closely to our body's energy levels. And, as we've seen, everything from our internal health to our external environment can change the timing of that conversation. And all of this leaves us with a pretty big, thought-provoking question. In our world where our diets, our lifestyles, and our environment are constantly changing, how is this delicate biological conversation going to adapt? What does the future of puberty even look like for the next generation? That's a question that scientists are working really hard to answer.